So for the first question, the question asked is evaluate the integral by reversing the order of integration. Firstly, we do the order of integration. We let x equals to set y, and we get y equal to x squared. So limit for x we get is 0 to 2, and limit for y we get 0 to x squared. Then we replace the limit for x and y. Then we integrate firstly with respect to y, and we get x squared exponential x cubed. Then from that we differentiate with respect to y. We let u equals to x cubed, du dx equals to 3x squared, and we get dx equals to du over 3x squared. And we replace the limit. We let x equals to 2, and we get u equals to 8. When x 0, u is equals to 0. So for the new limit is 0 to 8. Then from that we can get 1 over 3 in bracket exponential power of 8 minus 1. We get approximately 993.3193.
For the question 2, we need to find the mass of the lamina bounded by x squared plus y squared equal to 9 in the first quadrant. If the density function is given by del xy equal to square root 9 minus x squared minus y square. So we need to find the mass of lamina. So we have m equal to integration del dA, which is equal to integration del dy dx, and we know we need to change into the polar coordination, and we got limit for r is 0 until 3, while for theta we have 0 until pi over 2. We sub that value to the mass of lamina, and we have integration pi over 2 until 0, integration 3 until 0, square root 9 minus r square r d theta. How we get the square root 9 minus r square? We know r square is equal to x square plus y square, and then we let u equal to 9 minus r square, and du we have negative 2r dr. Then we have another equation which is pi over 2 until 0, 3 until 0, negative u power of 1 over 2 over 2 du d theta. And we integrate respect to the u first, and we get 9, and we get limit pi over 2 until 0, 9 d theta. We integrate the net respect to d theta, then we have pi over 2 until 0, 9 d theta. When we integrate respect to d theta, and we have 9 over 2 pi.
Question number 3. The center of gravity of a solid is x, y, z, and 9 is bar of the solid that is bounded by y is equal to 4 minus x squared, z equal to 4 minus y, x0, y0, and z0. With the density of delta xyz is equal to 1 over 4 minus y, and its mass is 16 over 3. So first of all, we need to find the mass of yz. So we sketch it to get the limit of x, y, z. Sketch it, and then we will get the limit of x 0 to 2, limit of y 0 to 4 minus x squared, and the limit of z 0 to 4 minus y. So write back of all the limits and puts the function of 1 over 4 minus y, x dz dy dx, and then integrate it by the inner part first. The first one, integrate with respect to dz, z over 4 minus y, put the value of 4 minus y, and then we will get the value of x, and then integrate next to respect to dy, and it will equal to 4 minus x cubed dx, and then lastly integrate respect to dx to x squared minus x power of 4 over 4, and then put the value 2 into the x, and then we will get the final answer of 4. And then for the final part, the question asks to find the x part, and then use the formula of myz over mass given by 16 over 3, 4 over 16 over 3, so the final answer will be 3 over 4. So for the question number 4, integrate 0 to 2, 0 to square root of 1 minus y minus 1 square, 0 to 4 minus x square minus y square to the function of 2x over square root of x square plus y square dz dx dy. And then we need to find the limit in terms of dz, dr, and d theta. So first of all, sketch the shape of the graph into the xyz axis, and then when we will get the value of the limit for the theta 0 to pi over 2 r 0 to 2 sine theta, and then for the z 0 to 4 minus r square. Start the value here, pi over 2 sine theta 4 minus r square, and change the function to 2r cos theta over square root r square r dz dr d theta. You can cancel out the square and the square root, r with r, so it will like this, 2r cos theta, then integrate by the inner part first, respect to dz, so it will be 2rz cos theta, put the value of 4 minus r square, you will get 2r in the bracket of 4 minus r square cos theta, and then expand it, you will get the 8r cos theta minus 2r cube cos theta, and then integrate respect to r, we will get value of, when we substitute the value of 2 sin theta, once we integrate it, we'll get the final answer of 16 sine square theta cos theta minus 8 sine to the power of 4 theta cos theta. And then for the last part, we need to sub the value first of the sine theta. You just let u is equal to sine theta, integrate it, and we'll get the du over d theta will be the cos theta. And get the value of new limit of 0 to 1. Substitute the new limit, integrate 0 to 1, 16 u square over cos theta over cos theta, so you can cancel out here, and then minus 8 u to the power of 4, same here, cancel out here, and then so the final part, just integrate it, 16 times u to the power of 3 over 3 minus 8 u to the power of 5 over 5. So substitute the value of 1, so the final answer we will get the value of 56 over 15.
For the question 5, we need to find the moment of inertia of the solid G about the z-axis is given by inertia equal to integrate G x square plus y square del xyz respect to dv, where the del xyz is the density of G, and we need to find the inertia of z-axis with the solid bounded by the sphere z equal to x square plus y square plus z square, and inside the cons z equal to square root x square plus y square. The density given is equal to 1 over z square. So we need to sketch the diagram in 3D based on the information that given, and we know that x square plus y square plus z square minus z is equal to 0, and we need to completing the square for z, and we have x square plus y square plus bracket z minus 1 over 2 square is equal to 1 over 4. From that we know that we have limit for theta is 0 until 2 pi, for phi you have 0 until pi over 4, and for rho we have 0 until 1 over 2. We insert the limit into the integration, and we set the value of x square plus y square is equal to r square, which is equal to p square sine square phi, and for del xyz we have 1 over z square, and we know z square is equal to p and z square is equal to p square cos square phi, and we have p square sine phi d rho d phi and d theta. Then we simplify the equation first before we integrate, and then we have 2 pi until 0, pi over 4 until 0, 1 over 2 and 0. Phi rho square sine phi sine square phi over cos square phi. Respect to dp, d phi and d theta. And then we integrate respect to dp, d rho first, and we have sine phi 1 minus cos square phi over cos square phi times with 1 over 24. Then we integrate respect to d theta. Then we integrate respect to d phi. Before that, we need to let the u equal to cos phi, and we have du equal to negative sine phi d phi, and we sub that value to make the new equation, which is negative 1 over 24 limit 2 pi until 0 limit pi over 4 until 0 1 minus u square over u square du d theta. Integrate respect to du and substitute back, and we have 2 pi over 0 2 pi until 0 square root 2 over 60 theta. And lastly we integrate respect to d theta, and we have square root 2 over 8 pi.